So good morning everyone. So now we will see the topic minimum cost spanning tree. So we already know what is the spanning tree, a graph without a cycle. It is nothing but a spanning tree, and we also know how to generate different spanning tree, or the number of ways we can generate the spanning trees. So now when this cost or weight factor is attached in the graph to the edges, then there is a problem to calculate the minimum cost of spanning tree. This concept is also called as MST. So there is a problem, find a MST for the given graph. So let's consider one example for this. Suppose this is one undirected graph, and let's consider that there are 4 nodes with some connecting edges, and let's consider partially connected graph. So this is a graph which is given, and we need to find the minimum spanning tree for the given graph. So what can be the solution, or how we can find the solution for this? So we can generate the spanning trees, and the spanning trees will be like, we can start from the node 1, then we go to node 2, then node 3 and node 4. Then we should not cover this 1 to 4, because otherwise a cycle will appear, and we also not able to cover this edge, otherwise there will be a loop, and we will mention the weight factors. So for this tree, the answer for the cost will be 5 plus 3 plus 6. This will come as 40. Then again we can have another spanning tree. We can again start with 1, we can come to 4, then we can go to node 2, then we can come to node 3 via node 2, and just mention the values. So for this tree, the cost coming is 4 plus 2 plus 3, so this is coming around 9. Again we can have some another tree. Let's start with 1, come to 4, go to 3, then from 3 go to 2. Please mention the values of the cost. So for this tree, the answer coming for the cost will be something like 13. And likewise we can obtain many spanning trees. So then how to find the minimum spanning tree? So after calculating all the different cost factors for different solutions of spanning trees for the given graph, we can combine them, and we can examine the cost of these spanning trees. For spanning tree 1, that is 14, for spanning tree 2, that is 9, for spanning tree number 3rd, there is cost 13, and likewise. So then we can come to a conclusion that this factor 9 is the lowest among all. So we can say that the spanning tree number 2 is minimum spanning tree among all, because it is having the lowest cost factor among all spanning trees that we obtain for the given graph. But in this method there is a huge drawback, that, or you can say that it is very tedious to go with this approach. by following this approach, you can see that we need to generate so many different spanning trees, and then respect to each and every spanning tree we need to calculate the cost. Then in third step we need to compare the cost, we need to examine the cost, and we need to find the lowest value, and then the lowest value or lowest cost factor will decide the minimum spanning tree among all the different solutions or sub solutions we obtain. So this is a very tedious approach, and this is not feasible in case of multiple or uh, huge number of nodes present in a graph, because in this example there are only 4 nodes, but in real time there will be hundreds, thousands, lakhs of nodes in a tree, and in such case to generate spanning tree for each and every solution or sub solution is very difficult. So this is not a good approach, and the solution for above approach is Prim's algorithm, and second one, that is Kruskal algorithm. So these are basically 2 algorithms. We will take help to find out the cost. Thank you, and in next lecture we will see these 2 algorithms.